afternoon, everyone. Today, we will be studying two methods used in the treatment of soft soil foundations: composite foundation reinforcement and geosynthetic material reinforcement. When high requirements for bearing capacity and settlement indicators are needed for soft soil subgrades, it is generally necessary to reinforce them using composite foundation reinforcement and geosynthetic material reinforcement. Composite foundation reinforcement typically involves the use of methods such as cement mixing piles or powder jet mixing piles to reinforce the base, improve foundation stability and bearing capacity, and reduce settlement. Specific methods include particle pile method, mixing pile method, and cement fly ash crush stone pile method. Now, let's delve into the specifics of composite foundation reinforcement. Firstly, the particle pile method utilizes crushed stone, gravel, waste residue, sand, and other granular materials. A pile is formed by drilling holes at specified locations using a pile driver, and the materials are then compressed into the soil. This creates a large diameter, densely compacted pile, enhancing bearing capacity through compaction, forming a composite foundation with the foundation soil. This method is suitable for compacting loose sandy soil, silty soil, powdery clay, and other foundations, as well as liquefiable ground. Depending on the filling material, the particle pile method can be divided into sand pile construction, as shown in the upper right diagram, and crushed stone pile construction, as shown in the lower right diagram. There are different construction methods for soft soil subgrade with different mechanical parameters. Vibratory impact compaction is suitable for soft soil foundations with a shear strength of no less than 15 kilopascals, while vibrating casing compaction is suitable for those with a shear strength of no less than 20 kilopascals. The construction processes for particle pile method and mixing pile method are straightforward and efficient. The mixing pile method involves using cement or lime as a solidifying agent. Specialized mixing machinery is used to forcibly mix the soft soil and solidifying agent in situ, creating a cement-reinforced soil with overall integrity, water stability, and certain strength. The image shows a foundation pit project reinforced with cement mixing piles. According to the different construction methods, mixing piles can be further categorized into slurry jet grouting piles and dry powder jet grouting piles. For slurry jet grouting piles, the construction process is shown in the left image, while the right image demonstrates the construction process for dry powder jet grouting piles. For slurry jet grouting piles, the slurry must strictly follow the mix ratio determined by the pile text. The prepared slurry should not segregate. The prepared slurry shall be put into use in time, and any slurry unused within 2 hours should be discarded. During the elevation of the drill pipe and grouting mixing, the drill bits should rotate in reverse while simultaneously grouting and lifting. During construction, parameters such as grouting pressure, grouting volume, drilling speed, and lifting speed should be continuously recorded. In order to ensure the construction quality, during the construction of power jet piles, compressed air shall be continuously sprayed during drilling to ensure that the ash injection port is not blocked and no water enters the drill pipe. During the elevation of the drill pipe and powder grouting mixing, the drill bit should rotate in reverse while simultaneously grouting and lifting. When the drill bit is raised to a distance of 0.3 to 0.5 meters from the ground, powder grouting can be stopped. During construction, parameters such as powder grouting pressure, instantaneous powder grouting volume, cumulative powder grouting volume, drilling speed, and lifting speed should be recorded. Particle pile method and mixing pile method are common methods for soft soil reinforcement, but the bearing capacity of subgrade after reinforcement is still limited. If further improved in bearing capacity is required, the cement fly ash crushed stone pile method can be used. The cement fly ash crushed stone pile method, abbreviated as CFG, involves mixing crushed stone, wood chips, sand, fly ash, and cement with water to form variable strength piles, as shown in the upper right diagram. This method is suitable for soft soil foundations with a shear strength of no less than 20 kilopascals. During construction, the vibratory pipe sinking pouring method is usually used for pile formation, and the construction equipment should be a vibrating pipe sinking pile driver. Prior to construction, pile process and pile strength tests should be conducted. The lower right image shows the on-site construction operation of CFG piles. During the preparation of CFG piles, the mixed material must be prepared according to the mixed ratio determined by the pile test, and the mixing time should not be less than 1 minute. After the pipe is immersed to the design elevation, feeding shall be carried out as soon as possible. The first feeding amount shall make the mixture surface in the pipe flush with the feeding port. Vibrating casing should be maintained at the design elevation for about 10 seconds, followed by simultaneous vibration, casing extraction, and lifting. If encountering a sealed layer, the extraction speed should be appropriately slowed down. During the extraction process, reverse insertion is not allowed. When the design pile spacing is small, construction should follow a skip piling sequence. So far, we have covered 3 methods of using piles to reinforce soft soil foundations. In many soft soil treatment projects, stronger geosynthetic reinforcing materials are often embedded in the foundation soil to further enhance bearing capacity. This is what we will learn next: geosynthetic material reinforcement. Geosynthetic material reinforcement involves laying reinforcing materials in artificial field embankments, forming a composite soil with compressive, tensile, shear, and bending strength. This enhances foundation bearing capacity, reduces settlement, and increases stability. The image shows the subgrade where geogrid is laid. Geosynthetic materials primarily serve 5 functions: reinforcement, filtration, drainage, separation, and protection. Specifically, reinforcement changes stress distribution in the soil, restricting lateral deformation of the soil. Filtration prevents soil particles from passing through, preventing damage to the soil structure caused by the loss of soil particles, while allowing water or gas to freely pass through, avoiding instability due to rising pore pressure. The drainage effect is reflected in the fact that specific geopolymers have high hydraulic conductivity, which can form a drainage channel, forming drainage channels for rapid water collection and drainage. The separation effect is reflected in using geosynthetic materials to isolate soils, sands, and stones of different particle sizes, or separate soils, sands, and stones from other structures, preventing mixing and ensuring structural stability and design functionality. When geosynthetic materials are used in slope projects, their primary functions are slope protection and erosion protection. There are many types of geosynthetic materials. From the table, we can see that they can be broadly categorized into geotextiles, geomembranes, geocomposites, and geospatial materials. Depending on material or form, they can be further subdivided. The selection of materials depends on specific project requirements. The 4 images illustrate the main application scenarios for 4 types of geosynthetic materials. Geotextiles can isolate 2 different filling media. Geomembranes are generally used for anti-seepage and waterproofing operations. Geogrids are primarily used for reinforcing and strengthening subgrades, and glass fiber grids are mainly used for crack prevention in road surfaces. Additionally, geocells, geobelts, and drainage belts are also classified as geosynthetic materials, and they are commonly seen in practical engineering applications. They are often seen in practical projects. Today's lesson concludes here. We have covered the key construction points of composite foundation reinforcement and geosynthetic material reinforcement. I hope you have gained an understanding and mastery of these techniques. Thank you.